Hello, Tim Barnes, OSU Extension, Marion County. Here's a short video about nitrogen inhibitors in the application of swine manure. Should be of interest to some of our integrators and also our contract finishers here in Marion County that use swine manure to fertilize their crops.
As mentioned, well, maybe not as mentioned, but as you saw probably when you saw the what the topics were today, we're talking about additives in manure, and I'm going to talk a little bit about nitrification inhibitors. So we'll first start with the Minnesota research. That's where I am. I'm at the University of Minnesota, and this was done by some of my colleagues. Jeff Vetch was the primary researcher. They did their work from 2011 to 2014, and the whole goal was to see if swine manure application timing with and without nitropyrin, which is also known as instinct, that's the manufacturer's name for it, and see how that affects corn grain yield as well as the nitrogen availability in the soil. Now, this is an older product. It's just instinct. I think there's a couple different versions out now, but this is one of the originals that came onto the market. In this case, they're using Finisher's swine manure. They wanted to inject 120 pounds of available nitrogen, first year available nitrogen, into the soil per acre. And they wanted to test application timing. So in this case, we're looking at before soil temperatures are below 50 degrees and when soil temperatures are below 50 degrees. So they went with early October, which was immediately after soybean harvest. Soil temperatures were still warmer than that 50. And they also did early November when the soil temperatures had cooled. And then within each of those, they tested 3 rates of instinct: 0, so no instinct was added, or 35 ounces per acre, which is considered the full rate by the manufacturer. And then because we're scientists, we figured why not double it just to see what happens. So 70 ounces per acre was considered the double rate. So first up, we want to look at soil nitrogen. Is this in fact doing what it says it's going to do? Is it preserving nitrogen? So what we see is soil nitrogen in pounds per acre from 0 to 100. And then we split it up into ammonium, which is the first red bar, and nitrate, which is the second yellow bar. And then we have our different timings: none, full rate, and double rate. And we also have October and November in there as well. I'll get on my little laser pointer here, so hopefully you can see my mouse. So what's interesting is if we look at the none, so this is a standard practice without any instinct in it, you can see that in October, there's a lot less overall nitrogen than in November. So just timing plays a pretty big role. And in October, you can see a lot more has even converted to nitrate. There's a higher concentration of nitrate than ammonium in the soil. In November, it's about equal. And then when we apply the full rate, you can see that in October, a lot more of that nitrogen stayed in the ammonium form. And if you add these 2 bars together, that's still more nitrogen than what we saw in October without the instinct. In November, it looks really good as well. So there's a lot more ammonium left in the soil than nitrate. There's still some nitrate. But again, this is good. And then with the double rate, it was very similar in November. We did see even more nitrogen preserved in October though as well. So this is the soil nitrogen going into the growing season. This is taken down to 12 inches of depth, and this is taken right before planting. So this is how much is going to be available to that crop going into the season. But overall, pretty good. We're seeing that it is in fact doing what it's supposed to be doing. And remember, this is averaged over 4 years of differing weather conditions. So overall, we're pretty pleased to see this. Next question always is, though, well, how does that impact the yield? Because that's great that we're preserving the nitrogen, but if it's not impacting yield, then maybe the cost isn't worth it. So here we have our yield in bushels per acre from 0 up to 200. We have our 2 different months where the manure was applied, either October or November. And then we have our different application rates of the instinct. So none is the first red bar, full rate is the middle bar that's blue, and double rate is the yellow bar at the end of each grouping. In October, we see that there are different letters above these bars. If any of the bars have the same letter, it means it's not statistically different. So we see that in October, without any instinct, the yield was significantly lower than with instinct. And that didn't matter if it was the full or the double rate. So in that case, it does seem like instinct was in fact enhancing yield. Now, in November, notice that all of these are the same. So statistically, there was not a difference in yield across these 4 years if it was applied in November with or without instinct. So that's really interesting. Basically, what this is showing us is that in this case, if you're using instinct or some other nitrification inhibitor in October, a few weeks before your soil temperatures get cool, this might be worth it. We don't have the economic analyses in this presentation about this, but obviously any increase in yield would have to offset the cost of applying the instinct. So in this case, this is more likely to happen if you're using it in October. If you're using it in November, though, when soil temperatures are already cool, maybe you're not getting the bang for your buck then, because maybe the cost of the nitrification inhibitor was not worth the very minute increase in yield that was seen. So that's kind of what we saw in Minnesota.